Hello and welcome. My name is Carlos Villegas and I'm here to present to you part 2 of a video tutorial on practical uses of cryptographic hash functions. In this session, I will stress the importance of using strong passwords and show you how easy it is to impersonate someone that does not use strong passwords. We are all very familiar with what a password is and that it's used to provide authentication, so I won't bore you with the definition. Instead, I am going to concentrate on dissecting the components involved in safeguarding our passwords, both on the user side as well as on the hosting server side, in hopes to create awareness on the importance of having strong passwords. Throughout this session, I will be doing various demos to increase the delivery of the topic being explained in hopes for a better understanding. At the end, we'll finish off showing you how to crack passwords using various techniques. Passwords provide authentication and are the keys to our money, our personal belongings, our intellectual property, and even our identity. Here are some real examples. Believe it or not, number 1 was 2014's most used password, followed by number 2. Both number 3 and number 4 are strong passwords. Let's start by testing your knowledge on strong passwords. Which of these two passwords do you think is harder to crack? I'll give you a few seconds to think about it. If you chose password A, then you are right. Password A is the hardest one to crack for one simple reason. It is longer by one character. With the best hardware on the planet today, password B can be cracked in 1 week. Whereas password A can be cracked with the same hardware in 1.8 years, all because of that one extra character. There's a few things to keep in mind. Both passwords use all 4 character sets. That is, lowercase, uppercase, numerical digits, and symbols. So just because one password looks more difficult to us to remember, it doesn't mean it's the hardest one to crack. From a password psychology point of view, assuming we don't know anything about the password, like for example, does it start with a letter? Is it only mixed case? Is it related to Star Wars movies and books, etc.? Then we must do a brute force. As a general rule, longer passwords are more secure because they take longer to crack. We need to stop thinking of passwords as single words and start thinking of them more as passphrases. A strong password is created by following 6 simple rules. Make sure your password has mixed case. Make sure you use numbers, symbols. Make sure your password is not in a dictionary of any language or has names that are real or fictitious. Make sure your password is unique for preferably every site. And the password length is very important, as we just saw. The longer is better. Ideally, they should be at least 12 characters in length. Let me show you a 2-minute clip that explains very well how to create a strong password.
This is Tom. Tom uses the internet every day. He logs into lots of websites, but he uses the same password everywhere. This is Tom's girlfriend, Jennifer. Tom likes Jennifer a lot. so he uses Jennifer01 as his password. But Jennifer01 is a very weak password. And a thief stole Tom's identity. What Tom needed was a strong password. Here's how you can make a strong password. Start by picking a phrase that's easy to remember. Change numbers and words that sound like numbers to numerals. Then use the first letter of each word. Add some special characters, and you have a secure password you can customize for each website you visit. Customize your password by adding a prefix or suffix made from the name of the website. For example, we'll add an Amazon suffix by using the first letter and the next two consonants in the name. Creating secure passwords is easy. Start with a familiar phrase, add special characters, and customize for each website you visit. Remembering these rules will help you stay safe online.
If I need to create a strong password, I would create one in the following way. It's no surprise to anyone that knows me that I like to drink a lot of coffee, and I mean a lot. For my phrase, I could use something like this. I drink 10 cups of coffee a day. If I follow the steps outlined in the video clip we just watched, my passphrase is transformed into the following strong password. I can then customize this password for multiple websites. Let's take the strong password that we created for Gmail. According to GRC Haystack's service, it would take about 13 billion centuries to crack using the best hardware on the planet. That means that this password is virtually uncrackable and an excellent candidate for us to use to authenticate ourselves online. Once you have a strong password, the server doing the authentication transforms your password into a cryptographic hash value, also known as hash digest. It does this by using one of many standard cryptographic hash functions, such as these. Let me do a simple demonstration of this on Kali Linux. Similar tools exist to compute hash digests in every major operating system. A cryptographic hash function produces a hash digest, which is what gets stored by the server doing the authentication. Cryptographic hash functions are cryptographic primitives that are mathematically non-reversible. This means that you can't go from this to this. This brings us to our second demo. In this demo, I will show you how to manually create a military-grade cryptographic hash value using 4 distinct ways. If you want to properly hash your passwords with military-grade strength, you want to use a hash digest called SHA-512 Crypt and use a unique salt. We will talk about salt in a few minutes. This is how we create a military-grade cryptographic hash value of a password using a Linux tool called Make Password. This is how we create a cryptographic hash value of a password in C language. First, we create the program that reads in 2 arguments and computes the cryptographic hash value of our password in C. Then we compile it. Then we run it with these arguments. And finally, we get our cryptographic hash value. This is how we create a cryptographic hash value of our password in Python. This is how we create a cryptographic hash value of a password in Perl. So far, I've been using something called salt without defining it. I think this is a good time to talk about salt and its importance. Salt is random data that is concatenated to every password before it is hashed. Individually salted passwords are harder to crack. This means that every password has a unique salt. The salt, the resulting cryptographic hash value, and the username are what need to be stored on the server in order to be able to authenticate a user when he or she logs in. Passwords that are not individually salted are easily brute forced, also known as cracked. Here is what makes salt so important. Salt is what protects your passwords against a very lethal common password attack, rainbow table attacks. Salt also allows two users to have the same password but a different cryptographic hash value. Rainbow tables are passwords' worst nightmare. Rainbow tables are basically huge sets of pre-computed tables filled with hash values that are pre-matched to possible plaintext passwords. Rainbow tables essentially allow attackers to reduce the time it takes to brute force to determine what the plaintext password might be in a surprisingly short time. So how would you prevent this password from being cracked in 11 minutes by a rainbow table or a dictionary attack? Salt is the simple answer. Remember to always salt your passwords with unique salt on every single one before you hash them. Now let's look at how salt is computed. Remember that salt is random data. So this command right here computes an 8-character random data in Linux. Let's switch gears and talk about another important aspect of passwords, the length. Let's talk about what the minimum length of a password would be that would deter me from trying to brute force it. Unless the cryptographic hash function is a very easy one, like for example SHA-1 or MD5, I wouldn't even bother trying to brute force any passwords that are 10 in length or more. So the longer the password means the slower it is to brute force. So if a cryptographic hash value came from an individually salted password, then the password length can be 12 or more in length to be considered reasonably secure. So once you've gone through the trouble of creating a military-grade cryptographic hash value for all your users, how do you store them? Let's talk about that. Passwords themselves are not stored anywhere on a file system or in memory unless you are building the world's most insecure system. As we briefly mentioned before, the cryptographic hash value along with the salt and the user ID are the only things that are saved on the server doing the authentication. Those three pieces of information is the only thing necessary to carry out the authentication of a user. For official guidelines created by our government, please see the following special publication. So how do black hat hackers get their hands on the password hashes? They can do it remotely by exploiting the device on your network to get an escalation of privileges and gain access to the password hash file or database. That's one method. They can also do it in person by plugging in a thumb drive or popping in a CD or a DVD into your server or workstation. Then they reboot it. Once it comes up, they copy the password-related files or databases to their thumb drives and walk away. It's that easy if they have physical access. Once they've exfiltrated the sensitive data, they can load it onto their offline password cracking hardware and number crunch away. The first hours or days of a password breach are the most important ones for a black hat because they have the element of surprise. So they want to maximize the number of passwords they can crack before news gets out to the general public that there's been a breach, which will cause everyone, hopefully everyone, to change their passwords. So the first thing they would run is a rainbow table attack, followed by a dictionary attack, because those take very short time. The remaining uncracked passwords are submitted to other types of cracking methods, such as a masked attack, a rule-based attack, a hybrid, a combination, and finally a full brute force, which takes the longest. The black hat hacker's ultimate goal is to get the password of a user with root or administrator privileges. So we've covered a lot of material. Let's do a quick recap. We went over what a password is. We talked about the importance of a strong password and what could happen if you're not using a strong password. We talked about what makes up a password using all 4 character sets such as mixed case, numeric, and symbols. Then we saw a 2-minute video clip on how to create a strong password from a passphrase. Then we looked at how long it would take to crack 2 passwords, and just by adding 1 additional character, it raised the cracking time from 1 week to 1.8 years. So we came to the conclusion that longer passwords are better because they take longer to crack. We went through 4 different ways of producing cryptographic hash values from passwords using the same salt on all 4 methods. And finally, we looked at the importance of salt and why it's important to uniquely salt every password before you hash them. They can safeguard against rainbow table attacks. This brings us to part 2. We are at a point in this session that concepts related to breaking cryptographic hash values have been explained. Let me demonstrate to you how to break them now. This is also called password cracking. Let's crack some passwords. Since cryptographic hash values are mathematically non-reversible, we need to use alternative ways to get from a cryptographic hash value to the original password. I will demonstrate how passwords are cracked using the following methods: dictionary attack, brute force attack, masked attack, lookup table attack. The first 3 attacks will need to be conducted on computers that have special hardware. This hardware is usually called GPUs, graphics processing unit. Some computers have 1, others have 2, 4, some have 25, and even thousands. Little side note here, it would be futile to try to crack passwords on hardware that doesn't have GPUs. It just would take so long that it's very inefficient. To do a dictionary attack, you need a dictionary. A dictionary is a text file of password guesses, one per line. Some people create them arbitrarily. Some people parse entire websites, such as Wikipedia and such, and create multi-gigabyte dictionary files. Let's create our own dictionary. We're going to add 3 words into it right now. Nothing complex. We'll just keep things simple for this demo. Let me give you some context to where we are at and where we are going. This cryptographic hash value we created from our password. In this case, BBB is our password, all caps. So this cryptographic hash value is what the attacker stole. At this point, he or she does not know what the password is. He or she only has this value because that's what he or she stole from the authenticating servers. Let's run our first dictionary attack to see if any words in our dictionary yield the cryptographic hash value. As expected, none of the passwords in our dictionary gave us the matching hash value that looks like our hash value. This means that we could safely conclude that our cryptographic hash value is not any of the passwords in the dictionary file. Let's try adding a new item to our dictionary. Let's rerun the dictionary attack against the same hash value with the same command as our first run. The only difference is that one additional item has been added to the dictionary. We added BBB, all lowercase, to the dictionary. As expected, we still didn't get a hit because our cryptographic hash value is for an all caps password of BBB, and the new item we added to the dictionary was for all lowercase BBB. This still means that we can safely conclude that our cryptographic hash value is not in any of the passwords in the dictionary file. Okay, by this point, I think you understand what's happening behind the scenes. Let's confirm this by adding our password to the dictionary file. Let's add all caps BBB to our dictionary and rerun the same attack as the previous 2 times. And this time we expect a hit. As you can see, this time we got a hit. Let me demonstrate a brute force attack. I want to simulate cracking a 4-digit PIN number, in this case 7856. Let's first create a cryptographic hash value of our 4-digit PIN. So we're going to attempt to run a brute force attack to see if we can crack the 4-digit PIN. Let's make sure there's no such file called crack.txt, which is where all the cracked passwords are going to get stored. Let's verify that the cryptographic hash exists. There it is. Notice the question mark D, lowercase, 4 times. That's very important. Basically, we're telling the password cracker, in this case Hashcat, to consider a 4-digit numeric digit password and do all permutations until the hash values match the one in our hash.txt. And there it goes. Here are some statistics of the current crack job displayed by Hashcat. And we got it. Let's see what's in our cracked.txt file. There's our 4-digit PIN. This proves that we have cracked a 4-digit PIN in about 6 seconds. Let me demonstrate a masked attack. Let's compute the cryptographic hash value of our password, in this case hello with a capital H followed by all lowercase. In the masked attack, it's important to note that each position is constrained by a character set. In this case, the U represents uppercase and all the L's represent lowercase. This is a masked attack. And here we go. Normal statistics being displayed. Notice how the estimated time to completion is 2 minutes and 30 seconds. And we're just about ready. Here we go. Bingo. Let's verify our results to see if it cracked the password. And yes, it did. Let me demonstrate a table lookup attack. This type of attack uses online services, or you could create your own, but there are a lot of services out there that you can leverage. First, we're going to create a cryptographic hash value of our password. It's going to be hello world. We're going to use this time a different algorithm. We're going to look at the NTLM, which is used by a lot of Windows ecosystem authentication servers. Now we're going to jump to a different web service called crackstation.net, and we're going to paste the cryptographic hash value that we computed for our hello world password. And we're going to click the crack hashes, and it found it as highlighted in green. Notice the results field. It says hello world along with the hash that we pasted in. This brings closure to this session. Thank you very much for your attention and your time. I hope you found it valuable.